Good morning. Today
Morning.
is June 15th, and this is the Cosmology Discussion Group. I'm Harry Ricker, and I'm going to give a talk today about stationary or static universe theories or ideas that have been put forward. It's just an introduction to this concept. They're not all tired light models. I'm going to talk about um, most of them are, but they're not all. Some models are attempting to get away from general relativity. Um, in the mainstream, I think that's being driven by the latest experimental results that are questioning the existing models, and we'll talk about that. So, is everybody ready to go? Anybody have any comments or questions?
Harry, we were talking some time ago about the work of Monty, and I've been away actually for the last few days, but I've prepared a few slides. If there's time, I could talk to them, or if not, some other time.
Well, that's going to be in my discussion. So why don't we put that later afterwards and see if you have anything to add to the. I'm going to talk about Monty. Um, okay. Let's see if I can get this to work here correctly. Well, it's working today. How about that? Yay. Okay. Can everybody see the is everybody can hear me and see the presentation, correct?
Yeah.
Yes.
Yep.
Oh, great. So I'm going to go start. Okay, so I titled this a stationary or static universe. Uh, and my main reason for this is I didn't want to, there are different theories, as I mentioned before previously in my introductory remarks. Um, so um, I think the issue has to do with the fact that the JWST telescope is discovering things or making observations that don't fit into the standard model, and so the mainstream is casting about for different ideas and explanations as to what's going wrong. So one possibility is a stationary or static universe instead of an expanding universe model, which is the current standard cosmology. I don't really like that word, standard cosmology. I don't know who invented this. That sort of seems to mean, this is the way you have to view things or else. Um, okay, most of the theories that have been put forward involve a tired light concept for redshift. I talked about tired light last week. I'll talk about that in a little more detail. Um, and the main point is that to have a stationary or static universe, um, you're not using general relativity. So general relativity is not accepted as being the valid model for the universe. So that's the important point. General relativity is not being used. Okay, now I'm going to start off with some history. Of course, everybody should know about this, that Einstein believed in a static, unchanging, eternal universe. And in order to make the universe static and eternal, he introduced the cosmological constant to make the unstable equations, the unstable equations of general relativity stable. So he stabilized the equations by introducing the cosmological constant, which has a long history and a lot of controversy associated with it. Then, of course, in 1937, Hubble said in his book, now a lot of people aren't familiar with this observational cosmology book that he did, which is um, usually the official version of it. light may lose energy during its journey through space, but if so, we do not yet know how the loss can be explained. So even Hubble recognized that there may be an alternative explanation other than the Doppler redshift, or which was what they were thinking at the time. The original idea was that the redshift is due to the Doppler shift. Of course, when general relativity came in to be recognized equations, then the idea that the space was expanding. But of course, nobody could tell us what space is. In 1954, E. Finlay Freundlich, and I can't really pronounce his name, Freundlich, which I think is German for friendly. He proposed an idea of interactions between photons would cause a redshift. And we'll see that idea. Other people in recent times have brought up that idea. And Groth-Reber, he proposed, now remember Groth-Reber discovered I guess I don't want to use the word amateur astronomer, but he was a radio astronomer, electrical engineer who built a radio telescope in his backyard and was one of the first to map out the Milky Way and radio emissions from the Milky Way. And he, even in 1977, Groth-Reber is still claiming that the universe was endless, boundless, and stable, as opposed to an expanding universe. So he's sort of a recalcitrant believer. So this non-believer would be correct. Okay, the tired light models. Does anybody have any questions about that brief overview of history there? Okay. So the tired light models, of course, we talked about this quite a lot. Zwicky proposed the first tired light model, which had to do with Compton scattering mechanism. And of course, that was claimed to be refuted by the lack of spectral broadening of the spectral lines that would presumably occur if you had Compton scattering, where a photon hits electrons and scatters off electrons. And that was the mechanism for energy loss of light. And I talked last week about Ashmore and his new tired light idea. And his idea is kind of like there's an absorption of the photon and a emission at a lower frequency. Then I'm going to talk about this today. Roberto Monti put out a paper in 1994 where he talks, his theory is essentially Maxwellian. He adopts Maxwell's equations, okay, and there's a damping term in the solution, okay, which is related to conductivity of space, which causes an exponential decay of the electromagnetic wave. But the decay is not very, it's not significant for nearby because the damping factor is pretty small. So you have to go a large distance in order to get a significant damping of the electromagnetic wave. And he does, and we'll talk about that later. Then there's this guy, Takai Musa, in 2020. And this is kind of a modern theory. He talks about tachyon field attenuation. So he's proposing that tachyons cause the attenuation of the electromagnetic waves and therefore explains the redshift. It's kind of, I'll talk about that a little bit later. Then we have another recent claim by this guy, David Redlin, in 2020, and he refers to redshift as being caused by attenuation. So all these ideas have the basic concept behind them as an attenuation of the radio wave, of the electromagnetic wave. um, causes the frequency to change. All right. Oh, okay. Here's David Schuster. This is 2008. He has this theory where he talks about the index of refraction of the cosmic medium is what causes the redshift. And then there's what's called the Wolf effect, which I really wasn't really too. Um, I read about this, and it's kind of a complicated thing. I'm not going to go into that, but if you go to the Plasma Universe webpage, they talk about the Wolf effect. So I think the Plasma Universe people believe that the redshift is caused by the Wolf effect. Okay, so now I'm going to talk about Roberto Monti. So does anybody have any comments or questions about what I've talked about so far?
Do you intend to explain the wolf effect a little better?
I have no idea what it is. It's got something to do with um, uh, light waves scattering against each other, and it's supposedly been verified in the laboratory.
Okay.
Do you know what the Wolf effect is? If you do, you can tell us about it later.
No, I don't. I'm just gonna go and check it out.
um, I tried to read about it, but I found that it was fairly complicated. So I decided that we can put that into a later discussion if people are interested in that particular concept. Okay, let's talk about Monty. Now, the Monty paper um, is really not about tired light or a theory of the universe. It's really about refuting relativity. And so he's not relativity, special relativity. Let me say special relativity. So the postulates of special relativity. So he's talking within the context of the first postulate and talks about redshift caused by attenuation. Okay, so what does this really mean? Okay, to really get down to the basic bottom line of it, Monty believes there's an ether. And so his theory is an ether theory. Okay, so he believes that there is a cosmic ether. And so then we could use the word cosmic medium, an ether-like cosmic medium. So he assumes a cosmic medium or ether, which has energy loss or disperses energy as the EM wave propagates through propagates, and the wave propagating interacts with the medium, and there's an attenuation of the signal of the EM wave. And then he invokes the equation E equals HF, which he justifies not necessarily as a quantum effect, but as the photoelectric effect. So he's trying to stay within classical physics to make Vladimir happy. Classical physics, his ideas are classical physics ideas, but he brings in the E equals HF equation through the photoelectric effect, and that's his justification for the change in frequency. So the loss of energy in the EM wave due to the quote conductivity of the medium, okay, and applying the Maxwellian theory, which gives you the solution in a conducting media, and that solution is a attenuating or exponentially attenuating electromagnetic wave. And then he says, now the galactic redshifts could obviously be attributed to the damping of the electromagnetic waves emitted from the various galaxies in random motion within a stationary universe. Yay, so there we are. We have a stationary universe because the redshift is not attributed to the expansion of space. Okay. The Monty model predicts a logarithmic law of attenuation versus the Hubble linear law. So he makes this point in his paper, and he doesn't. He tries to present some. How should I put this? Examples of this law that he's come up with. He's essentially applied this exponential or logarithmic law of attenuation to measurements, galaxy measurements, redshift galaxy measurements. And there, in this particular paper, the experimental evidence or the results that he presents are very, how should I put it, simple. They're brief. And apparently he has other papers which he references in which he gives more details about how he compares the logarithmic law versus the Hubble law. But those papers are not really that easy to find. And I did locate one, but it's in Italian. So I couldn't read it. So there may be others out there that aren't in Italian or maybe been translated into English. Apparently, this wasn't something that mainstream people were really excited about. And so it kind of it's sort of obscure. So he shows that in any case, the logarithmic law fits the experimental data much better than the linear law. Moreover, it has no problems with the age of the universe. That's his quote. That's what he says regarding his comparison of the logarithmic law versus the accepted Hubble law. And then he goes on to say, observations of the apparent magnitudes and redshifts of quasar and galaxies clearly show that an extraordinary luminosity is associated with these celestial objects if a linear law is adopted. Okay, so the main point of this, and I think this is really kind of significant, what he's claiming is that these, when they apply the standard model of cosmology to look at the data, what happens is that they apply these corrections, and the model that they're using, which is usually a Friedman type model, a general relativity type model, it puts these objects, the galaxies and quasars, further away than they ought to be, according to Monty. And so what happens is that you get in order to, when you calculate the absolute magnitude is the definition of the absolute brightness on an absolute brightness scale. You get absolute magnitudes or brightnesses that are way higher than people expected. And so you have these energy discrepancies in quasars, okay, where the quasars are emitting far more energy than they ought to be. And quasars being highly redshifted, that implies they're really, really, really far away if you use the what he calls the linear Hubble law. Okay. And so his claim is that astronomy has miscalculated the brightness of quasars and other galaxies where they calculate these very, very, very high levels of brightness, which I think is kind of interesting because that basically kind of gives an explanation for some major discrepancies in cosmology. Okay. And then he goes on to say, in my opinion, these extraordinary luminosities and velocities are due only to the extraordinary distance that is attributed to these objects according to the relativistic linear law and the hypothesis of the expanding universe. Okay, so I put in here, in other words, the brightness of distant objects have been incorrectly calculated. Well, that's a big oops. Okay, you haven't calculated the brightness of galaxies and quasars correctly. That's a big oops. Okay, does anybody have any questions about this? No question.
Why is the linear law associated with either special or general relativity?
The linear law is Hubble's law.
But I was at, in your slides, you were talking about it's associated with the with relativity.
Well,
Why
what relativity tries to do is they try to explain the linear Hubble relation. The Hubble relation relates redshift to distance in a linear manner.
Yeah, but that's just stating my one half of my question. How is that related to the theory of relativity?
I don't know. Read his paper.
I may be able to come in on that later when I say a few words about the conductivity business.
Yeah, because it just seems like anything that's observed, it's something supporting or related to general or special relativity. And this is sort of mystifying.
Well, he's saying,
it's like pulling a rabbit out of.
I don't know if you missed it or not. He's saying they're wrong. He's saying that's wrong. That's an incorrect interpretation.
Right. But why was what was the basis for the interpretation in the first place? Or perhaps
I'm not sure what are you asking?
Well, I mean, this association between the linear law and relativity, if it's wrong, okay, but why were those two things associated in the first place? I don't see anything in
because the relativity
special or
models
general.
have to agree with the Hubble law, which is an observational fact.
So
But
maybe
anyway,
just very simply, if you
really,
put, if you
you're
put it,
asking me to explain his claims about linear versus the logarithmic law, and I'm only reporting what he says in his paper. If you don't like what he says, perhaps you should read his paper.
see, I can explain this, but I don't know if you want me to answer it now or
All right, go ahead, answer it now.
Okay, okay. I'll answer it in simple terms, Jim. If you take a conductivity term in the Maxwell equations, you get a dissipation. You get like a telegrapher's equation. It's a dissipation depending upon the conductivity. Now, uh, the theory of relativity actually takes that conductivity to be zero. It doesn't it doesn't include that. So you get a linear law. You get no dissipation with distance. You get.
Oh, okay. Thank you.
Is that okay? That's a simple.
I was wondering why people were associating these two things, not questioning Monty's conclusions.
It's a good question.
Ian. That clarifies it for me. Thank you.
All right. Any other questions here? All right. Now I'm going to talk about the tachyon field attenuation by this Japanese fellow. From the assumption that intergalactic space is filled with tachyon plasma, it can be shown that the cosmological redshift can be explained by electromagnetic attenuation in the tachyon plasma field. According to this model, the photon propagates in a superluminal speed between intergalactic space. Is that really? By using
fiction. A bit like science fiction, I might say.
Yeah, he doesn't really tell me what a tachyon is, though. But does everybody know what a tachyon is?
Well, I think it's something that appears in computer games.
No, it's a particle that travels faster than the speed of light.
Oh, really?
Am I not correct in this?
You are correct, sir. Yes.
The only reason I'm mentioning this is because I think it's kind of interesting what he's going to say. Okay, his conclusion is kind of you may not agree with what he has to say about his theory. It says by using the tachyon field instead of dark matter, because of the tachyon repels with ordinary matter. So what he's saying here is, I don't need the dark matter hypothesis. Okay. So that's kind of, he's sort of sidestepped the dark matter issue with his theory. Okay. And then from which the recent observational result that cosmic expansion is speeding up can also be explained by the exponential attenuation of electromagnetic waves. And apparently I didn't copy that correctly. So he's saying that not only can I explain dark matter, but I can also but by getting rid of it, I can also get rid of dark energy. And so he's proposed a model in which he gets rid of dark matter and dark energy by his tachyon model. That's kind of interesting. I thought that was interesting because of the fact that we don't need this dark energy, dark matter thing. Okay, then we have this IGM, intergalactic medium model or theory by Schuster. Huh? Okay, and then intergalactic medium, he claims that the intergalactic medium, this is another ether theory. Now, remember here, when we had the tachyon field, this isn't an ether theory so much. Okay, I don't see a tachyon field as being an ether theory. It's just saying that the medium is a field of tachyon particles, whatever tachyon particles are. So it's not in my mind, not a classic ether theory. This theory here, he's implying that there's some kind of an ether in the intergalactic medium, and that the intergalactic medium refracts the spectral, and what he calls it, says it refracts light. Now, it's not real clear to me whether or not this idea is really correct physically or not. He says, averaging over cosmological distances, it is reasonable to consider the IGM a super low density fluid. Modeling the IGM, intergalactic medium, in this manner does away with the idea that light propagates exactly at C through intergalactic space. Instead, the IGM now has an index of refraction. So he's adopted an ether concept. And so this mass density creates an index of refraction that shows the light, slows the light down, and causes an apparent redshift. So his idea is the redshift is caused by a medium through which the light is propagating. Does anybody have any questions about that? Okay, we got 10 minutes here. I don't think I'm going to finish this up. Modified tired light Wolf effect assumes a steady state universe that is infinite in both expanse and age, with the observed redshifts caused by particle interactions, creating an overall index of refraction of the universe. And of course, this is kind of similar to what we were talking about before. So the photons are interacting with each other, is my understanding of what he's talking about. And this occurs in a cosmic medium plasma. So we're back to the plasma again. And supposedly this idea is predicted by Wolf to account for discordant redshifts of quasars and verified by laboratory experiments. So we sort of had a conversation about this. Apparently the experiments, or where they verify this, is they have two laser beams, and one laser beam interacts with another laser beam, and it causes a shift in the frequency of the light. Now, I can't really claim that I really looked into this closely enough, but that's supposedly how this is verified in the laboratory. If you're more interested in this, we can talk about this in another session. If somebody's interested in looking into it and explaining it in some detail, I'm just kind of giving an overview of talking about the different ideas that have been proposed. Okay, here I'm going to talk about, I've put in two categories here. One is this Lumbrizer and then Lavalette. Cosmology without general relativity. The Lucas Lumbrizer is recent, like it's 2024. And the internet, YouTube has a video about this that attracted my attention. And it supposedly claims that the universe is pervaded by an energy field that is the ether. So there's a field of energy that pervades the universe that acts sort of like an ether. And of course, that idea is kind of in some of these other theories that I've talked about. The problem I had with it is when I went to look at his paper, I couldn't find anything about an energy field pervading the universe. What his paper is about is a cosmological theory that doesn't use general relativity, but assumes Minkowski space. But Minkowski space is basically flat stationary space and that's special relativity. So Minkowski space is basically special relativity. So what he's done is he's saying, I'm not going to use general relativity, which involves curvature of space and time. I'm just going to stick to special relativity and do all my equations in special relativity. Okay. Lavalette proposed this idea in 1986, which he calls subquantum kinetics and ether theory. Now, that's kind of, when I looked at it, it's not really clear to me that it's an ether theory, in the traditional sense that they're ether particles. It's kind of a quantum physics ether. Okay, so here's the cosmology and Minkowski space. This is the Lucas Lumbrizer idea. And he starts off in his paper and he gives a litany of all the problems with the standard cosmology, the lambda CDM cosmology. And they're all the problems that we've talked about before. So if you're interested in reading about this, it's a kind of a synopsis of all the issues. I find that this is kind of a funny little joke here. People say there are only two problems with the lambda CDM cosmology. One is lambda and the other is CDM. And that's apparently a joke in cosmology. But if you think about it, it sort of defines what the issues are. Lambda being the cosmological constant, which is dark energy. Yeah. And then the other problem is CDM, which is the dark matter part. So essentially what this joke is saying is that we've got dark matter and dark energy, and neither of those two things make sense to us. And so that's a real problem. And so I think in the mainstream, and this Lumbrizer is obviously a mainstream guy who's working within the mainstream paradigms. There's a problem going on here. They're talking about this. They've recognized there are problems, and they're looking for solutions. So he's proposed the flat Minkowski space and a static universe. So he's going back to the static universe idea. However, rather than due to the expanding space, redshift is caused by evolving particle masses. Now, this is kind of interesting because this kind of goes back to the Dirac idea. We've heard about this idea from Vladimir and his idea. You may not know there's a similar type of idea that the masses are changing. The mass of particles are changing. Okay, And he doesn't really give a mechanism for how this happens. It's kind of, I guess, something that you have to look for by reading his paper and trying to figure out his complicated transformations. It's a very complicated mathematical theory. Okay, and the redshift is because the different masses between the emission and reception. So in other words, when we have an atom, the mass of the electrons in the atoms are different. They're not the same. So when the light wave was emitted by the transition in the atoms, the mass is not the same as the mass that's used in the laboratory for comparison. Okay. All right. Rather than an expansion of space, spatial curvature, and small, this is a quote from his paper, rather than an expansion of space, spatial curvature, and small scale inhomogeneities and anisotropies, this frame exhibits a variation of mass, length, and time scales across space-time. Alternatively, this may be interpreted as an evolution of fundamental constants. That's the Dirac idea, I think, kind of modified. Okay, so then my comment at the bottom is he's relying on Minkowski space, which means that his whole entire theory is based on special relativity, and we know special relativity is refuted by a lot of evidence. Okay, now going back to Monty's paper, okay, Monty's paper is really a review of the experimental evidence regarding special relativity, and he shows that special relativity is refuted by the experiments. So there's a problem in adopting this idea of Minkowski space because you're adopting a theory or a concept of space-time that doesn't conform to the experiments. All right, does anybody have any comments or questions about that? Okay, and we're going to get cut off here pretty soon, I think. Probably, so I'm going to stop here, and so it's like about a minute left to go before it cuts me off. I don't want to get cut off in the middle. So anybody have any comments, questions to introduce? So
well, this association of general relativity with various cosmologies is really thin intellectually. In other words, general relativity apparently refers to some collection of phenomena which we can put under the rubric of gravity or gravitational phenomena. But it tells us nothing about how particles form, how atoms form, the periodic table, chemical reactions. It really tells us nothing about the science of how our universe works.
Okay, I guess we're recording. Okay, Jim gave a very good rant against general relativity. Now, the point I'm making about that, the whole point of this talk is that people are looking for a way to get away from general relativity. They're looking for alternatives. It's not, I'm not claiming that this is an exhaustive catalog of theories. These are just what I was able to find, you know, by poking around on the internet and starting off with Monty's idea, and looking around and seeing what else is out there. These are people that want to get away from general relativity. Okay. All right. Okay. I did go over, and before I wanted to get to this, this is kind of an interesting, this guy, Paul A. LaViolette, has done some rather extensive work, it looks to me. And of course, a lot of this work that he did, I think he started off with this idea, this theory that he had about subquantum kinetics, I think is the name of it. I think that was something that he did in the late 60s, early 70s as a thesis when he was in for his doctor's degree. I would assume. So I got the impression that that's where he started studying this idea, and that sort of grew into a theory. And he's apparently done a lot of work on this theory. There are a lot of papers out there. I wasn't really that interested in a lot of the details. I was more interested in his experimental tests. So what he did was like what the cosmologists do, where they try to test their theory, and they try. There's a lot of different tests of a cosmological theory, and we haven't really discussed that. This is kind of a technical thing, what how cosmologists or astronomers, if you will, test a cosmological theory. It's a complicated thing. They use multiple tests, and they try to come up with a theory that agrees with all their multiple tests. And of course, a lot of the tests are kind of like, how did you do the test? How did you reduce the data and that sort of thing? There's all these corrections that are put into these tests and a lot of stuff. So it's all kind of arcane, hocus pocus kind of stuff. But what's interesting about this is that he developed a test of his theory of a static universe versus the data, and he comes to a different conclusion. Okay, and so the name of the paper here is "Expanding or Static Universe: Emergence of a New Paradigm," and this is published on the same publisher that Vadimir's theory. It's Script, I think, but anyway, it's at this is the web address here, so people can look it up if they can read it. Probably just easier to Google "Expanding or Static Universe: Emergence of a New Paradigm." So anyway, that's where this comes from. Okay, so he says the no evolution. Okay, evolution meaning the universe isn't expanding and changing with time. That's kind of essentially that's part of the standard cosmology. So no evolution, not standard cosmology. Tired light model makes a better fit than the expanding universe hypothesis when compared to the observational data of 7 cosmology tests. So he's claiming that the static universe, no expansion, the universe isn't expansion, the tired light model provides better tests, passes the test better than the standard model does, including results of the radio galaxy differential number count test, the total number of tests favoring the no evolution static universe tired light model comes to 9. So he says he's done 9 cosmology tests, and the static universe model passes with flying colors. I think that's kind of interesting. I think that's kind of important to think about. Maybe he's right. Maybe maybe there is a static universe alternative to the current existing cosmologies based on general relativity. So that's basically, I think, the important takeaway. Okay, so I think I went ahead here. So what to like about the static theories is kind of my summary of it. We'll get to the summary of it. They claim to agree with the observations better than the Big Bang model. Okay, I'm summarizing and kind of making it simple. Now, remember, this was a claim that Monty originated, and Monty's paper was about in the mid-90s, and I think it was in 1995 or something like that. So this is what Monty originally claimed in his paper, although he didn't go into a lot of detail in that paper, but he did reference other papers that he published where he supposedly puts forward the data. But as I mentioned there, I think they're in Italian. Then we can remove the energy discrepancy, emission discrepancy, since objects are closer than in the Big Bang. So in other words, we don't have these problems with like quasars emitting these tremendous amounts of energy because they're not, they've overestimated their distances. So they're not as far away as they think they are. And so that removes the brightness discrepancy, if you will. The other thing to like about it is getting rid of the dark matter and the dark energy. We can get rid of those. Now, I talked about, referred to the tachyon idea where he tries to get rid of it, those dark matter and dark energy. Some of the other models try to do the same thing. If they're more recent, if they're older, they like Laviolette, his idea goes, his theory is much older than the dark matter and dark energy came into it. But maybe, and I haven't looked into this in detail, but this is one of the things we want to get rid of this dark matter and dark energy. That's one of the main things that critics want to accomplish. And if you like the no creation idea, there's no event of creation. The universe is eternal and has always been there. It's eternal and boundless, which was what the radio astronomy guy, I'm trying to think, Grieber, he held on to that idea until he died. The universe is eternal, boundless, and that's his idea. It's not expanding, it's eternal. So we don't have this creation event, this singularity, this Big Bang thing in these static universe models, because if the universe is not expanding and it's static, there's no justification for having a point of origin in the Big Bang. Okay, now this is the last point here I think is kind of interesting, and that is this idea of the redshift caused by, not by the expansion of the universe, but by a energy loss mechanism as the light waves or the EM energy passes through the medium of space, kind of can be looked at as a evidence for ether. So if you like these theories and believe in them, then you can claim these theories prove that an ether exists if you accept them. So you could say the redshift is evidence of an ether.
Can I interject?
Huh?
Can I interject?
Sure, go ahead.
The cosmic medium, as we know it, is 99.9% plasma.
All right, well,
the light is passing through plasma.
Right,
That's what
right,
the medium.
Right. Okay, that's kind of going off topic. Okay, now we have what not to like. Energy attenuation mechanism used causing redshift is discounted. So if you are a traditionalist, you don't really want to believe, you say this energy attenuation mechanism of tired light. That's just plain wrong. It's not right. It's not physics. Therefore, it's wrong. So I object to it. So that's a problem. Most of these theories do not address creation or cosmogony, which, in other words, they don't propose how matter comes into existence. So that's outside of the boundaries of these ideas. Then there's a big problem. They don't really address where the CMB comes from, the cosmic microwave background. They don't really address that issue. So that's kind of a difficulty there. And of of course, then they do require an ether or cosmic medium contrary to the first postulate of relativity. So if you believe that, in relativity and that Einstein proved that ether doesn't exist, you're not going to really want to accept any of these theories. So anyway, that kind of sums up my little introduction here. So, Rick, if you'd like to, you can go on about plasma if you want now.
Well, I was just saying that they're saying that light is passing through the cosmic medium. Well, we know that the cosmic medium consists of plasma, charged particles. And when light passes through and hits an atom or an electron, it gets absorbed and then re-emitted at a different frequency. Sometimes the same frequency, sometimes a different frequency. I think that's the mechanism for tired light.
Well, that's the new tired light model that's discussed by Lyndon Ashmore in his book. That's a good synopsis of it, huh?
He might be right.
Okay. Any other comments, or can we?
All I would personally say for sure, at least in my opinion, is that the Big Bang wasn't the beginning of the universe. Whether there's an expansion of some sort of local expansion, I don't personally know. I mean, as far as the evidence for the static universe, I mean, where I guess light interferes with other light or something, or tachyons, which are theoretical. I mean, I don't know how well that explains the redshift. I mean, I admit that I don't know what causes a redshift. Anyway.
So I'm not sure what you're trying to say.
Really? Well,
you're saying you don't know, and I mean, yeah, of course you don't know.
Well, I mean, I would say I think for certain the Big Bang wasn't the beginning of the universe. I don't think there ever was a beginning. And I mean, as far as the tired light theories, I mean, tachyons are theoretical particles. I mean, they haven't been proven to exist, have they?
Well, I just brought that up as a interesting. It's recent, and it's kind of an interesting idea. I'm not advocating it or anything. It's just, the point is that people are looking for alternatives to the expanding space paradigm, because the expanding space paradigm that's incorporated into the standard cosmology, that paradigm is disintegrating due to the claimed recent evidence of the JWST. Yeah. However, my view is that you could have predicted that based on what Hubble was finding, but Hubble was only giving you kind of a taste of it. But JWST is now hitting them in the face, so they can't dismiss the fact that the Hubble was finding these fully formed mature galaxies at very large distances in its photographs, and they kind of push that aside. But now with the JWST, they're finding these fully formed mature galaxies that supposedly formed 400 million years after the Big Bang, and they're going like, this is not possible according to our theory. So they're looking for alternatives.
And now they're finding little red dots even further out.
Right. Who knows what they are?
Galaxies.
I have just an editorial comment on terminology. I think the term static, I understand why it's used to contrast it with the creationist views of the Big Bang and so forth. But I think the universe that we have now is anything but static. I mean, things are changing all over the place. So it's just an editorial comment about terminology. I think in the future the term static will be dropped. It's the universe.
I think what they're referring to is the non-expansion of a Big Bang. Like that's all that static means, is it's not expanding. It's there the universe is dynamic and stars are moving here and there. That's a given. That's observable. We see that, but it's not expanding outward like an explosion would in space,
Yeah,
expanding out in all
I'm
directions.
just making a terminological,
Yeah,
very minor, teeny little point that I just think the term static is down the road is sort of misleading. I mean, stats.
Dyna dynamically static. How's that?
How about just the
No,
universe?
you're right.
You don't need an adjective there.
I have a question. Did anybody discuss blue shifted galaxy? How to explain blue shifted? Beginning from Andromeda.
Well, the main, I'm just introducing to you theories in which people are trying to explain the redshift as not being caused by an expanding universe according to the models of general relativity.
What about blue shifted?
Obviously, blue shifted galaxies are a problem in any tired light universe if your idea is that the light is attenuated on its traveling to Earth. So blue shifted galaxies would have to be traveling a lot faster towards us than we think.
It could be also that it could be as ARP says that it's a measure of youth of an object, how red shifted it is. And as it gets older and older and older, it starts to blue shift.
My goodness, it's a bullshit.
Okay. Halton Arp was a well decorated, he studied under Hubble. He knows his stuff. Okay, you can say it's bullshit, but I don't think so. I think he knew what he was talking about.
But if
Talking
we
about
took the
Andromeda,
Doppler explanation for the shifting of the spectral lines, together with a non-Big Bang conception, well, then on average there should be 50% of galaxies blue shifted and 50% red shifted. Now, my understanding is the vast majority, with almost no exception, you mentioned one, the Andromeda, are red shifted, and therefore we seem to need an explanation other than the Doppler explanation.
That's where tired light would come into effect.
That's right, yes.
So it's a combination of different phenomena.
Well,
Name
I
this
don't know if it's a
phenomenon.
combination. I mean, it depends what you're looking at. If you're looking at the red shifting of a spectrum moving against a gravitational field, well, that's another phenomenon. Yes, it's another phenomenon. But we're talking about the widespread red shifting of spectral lines generally observed in the universe. And there are other phenomena, such as the gravitational effect and so on and so forth. But there are other phenomena. So in the universe as a whole, one might not say it's generally a combination of them all. There seems to be some effect which is causing a diminution of the energy reaching us from these distant galaxies, and that's what we're trying to explain.
Right. And well, in Halton Arp, his Atlas of Peculiar Galaxies shows quasars physically attached to a blue shifted galaxy, and they're highly red shifted. How to explain that?
Yeah, that's
And
another phenomenon. That's another.
that's a measure of youth.
Please, please.
A galaxy is spitting out a quasar from its black hole, and it's congealing into a little quasar and being spit out of the axes of the galaxy and along the spiral arms as well. These quasars are birthed two different ways.
Each
Vladimir,
of everything. One second,
Vladimir,
guys.
Vladimir, what is your view of what is your explanation for blue shifted galaxies, though?
One second. Let's talk about the existing theory we're talking about. It's not my business, it's our business with all. Blue shifted means that you get additional energy. Where from? What is the mechanism? And so on and so on. I don't care about anything, especially about my model. It's another story. Many times I told you about. And what is important? It's not equal number of blue shifted and red shifted. Blue shifted Gupta about 10 years ago, he calculated all of them. It was 8,300 blue shifted galaxies. All the rest red shifted. But even these 8,300 blue shifted galaxies, we must explain. The second very important point, Andromeda, it's a very close, the closest galaxy to us. To talk about these billions of light years distances, very big one, it's not, it's the closest. And nevertheless, it is moving to us, or it gets additional energy. What is the mechanism and where we took it? Simple like this, guys. Andromeda is
Well,
a very
the
good
claim
example.
is that
No distances.
the claim is that the Andromeda galaxy is going to collide with the Milky Way.
Yes, but it's why? Because they measured blue shift and they calculated based on a blue shift the speed of this galaxy, and they calculated when they will collide with Milky Way. But blue shifted, please explain me in any theory. Blue shifted. Guys, all of this theory you named
Well,
today
hold
about
on,
redshift.
hold on. A
Yes.
lot of this claim about blue shifted galaxies precedes a number of these tired light models.
Precedes.
Yes, I don't know of any of these tired light models that deal with the claim of blue shifted galaxies.
But you cannot go against energy conservation. If you have blue shifted, show me where you got the additional energy. Simple like this.
Well,
And all these tight
the
lights,
models
it's
don't
only
agree.
redshift.
The models don't address that issue, and I don't even think that the standard cosmology address that issue.
Right?
The standard
You
model
are
address this
right.
issue? I don't know.
You,
Vladimir, what is your explanation for blue shifted galaxies, though?
I think
I wasn't clear. I don't know.
yes, I gave you so many times the same example. We have our solar system. We have planets moving around. In one moment of our time, Mars or Venus moving out of the Earth. We have redshift. Sometimes these planets moving towards us. You have your blue shift. It's as simple like this. Why all these red-shifted galaxies, all this stuff? They claim that they rejected Big Bang model. Wrong. Because only if you have your center of expansion, you have all the galaxies going outside, then all of them will be redshifted. You see what I mean? In my model, there is no overall expansion of universe. There are superclusters like our solar system, center of superclusters, and all galaxies moving around this center. It's a good model solar system. It's a good model of supercluster. And inside of these superclusters, the movement of each galaxy depends where we are and where the other galaxy is. Some of them moving to us, some of them going out. That's why there is no for them, for redshift, blue shift, and so on and so on, because it's based on a Big Bang model explanation. In my model, no, you cannot do it. Inside of supercluster, you can find blue shifted, red shifted. It depends on relative of galaxy against Milky Way galaxy. Simple like this, guys.
Okay, Jerry, did you understand that?
I have to admit
He's
that I
explained
didn't.
this. I
Well,
mean, I can't imagine 20, 30, 40 times he's explained this.
well, okay, Vladimir, do you think that redshift implies that the galaxies are rushing away from us? Redshifted galaxies. I mean, if blue shifted galaxies are rushing towards us, redshifted galaxies are rushing away.
Yes, I
You
told
don't agree with the
exactly.
Big Bang, though. So I'm confused.
You're confused. Let me ask you the question. Blue shifted inside of the standard cosmology. How you explain? You personally.
I admit that I don't know.
You don't know. That's why you cannot take my explanation for 20
I
times
don't
already. I
understand your
repeated the same.
explanation.
Huh?
I don't understand your explanation.
His explanation is that that the galaxies are moving around in space, and because they're moving around in different directions in different orbits, there's some of them that are moving towards us and some are moving away.
So all the redshifted galaxies are rushing away, though. If that is so, why would you reject the Big Bang theory?
You know, it's unbelievable, Jerry. Even after explaining, Harry, you don't understand. I don't know who can save you to understand you. Maybe God, maybe somebody else. Because Harry is the best guy who can explain everything. And even him, you cannot understand. I'm so sorry, man.
Well,
It's
Vladimir,
not my problem. It's your problem.
I thought that your theory suggested the small puff, as Jim refers to it. You know, where there's just a slight growing out of the 4D nucleus that created everything somehow. I don't see how that would cause a redshift, which you seem to believe in.
I gave you a very simple example of our solar system. Do you know our solar
Well,
system?
okay, so when you look at planets that are receding away in the planetary orbit, they're really blue shifted and red shifted because that isn't very high velocity.
Well, they're red shifted when they're moving away and blue shifted when they're moving towards us.
Okay, I didn't realize that because I didn't realize there was that much velocity to register that. However, though, if redshifted galaxies are rushing away, why is the 4D nucleus in the small puff a valid theory?
All right.
I've got another question.
I think we're getting off topic here, so let's just
The
try
only
to
thing that
talk
would
about-
explain the massive galaxies being redshifted is if the Laniakea supercluster was expanding.
That's possible too, yes.
That's the only thing that could explain that many redshifted galaxies not using a tired light theory or a youth versus age theory. That's the correct me if I'm wrong, Vlad, but if you say that all the galaxies are, or majority of them are redshifted, the Laniakea supercluster would have to be expanding, correct?
A little bit right and a little bit incorrect. Let me tell you one more time. Laniakea supercluster is a mother of our Milky Way galaxy too. There are 100,000 galaxies moving around supercluster, Laniakea supercluster center, and all of them moving in different directions, like planets. You see, in our system, we have 10 planets, supposedly. In Laniakea supercluster, we have 100,000 galaxies. And they're not their movement from this singularity. They start their movement as a result of some kind of explosion, firework of the center of Laniakea superclusters. All these galaxies moving around the center. There is no correlation to Big Bang model, to initial singularity. Forget it. It's like a solar system.
Forgive
And this
me,
one,
forgive me if I'm wrong, but they're looking at the the supercluster as an attractor, and it's pulling galaxies in towards us, towards
or
the center
attractor,
of the.
yes, you're right. You have the
There,
right
how
definition.
if everything's being pulled in together, that should make everything blue shifted, no, not red shifted. It's a contradiction there.
Well, I have a question to ask about how they're calculating what they're doing. I think when they claim these clusters is they're measuring redshift and they're using redshift as a measure of distance. So
I understand.
they're assuming the redshift, the Hubble relation, and when they're so they do these diagrams, that you see where they show the clusters.
And
Those
it looks like they're all flowing in towards the center. And yeah, I understand.
Well, my point is they're based on the assumption of the cosmological redshift is expansion of space. So I'm not really sure what they're measuring there. I mean, if you're saying that the redshift isn't a distance of correct measure of distance according to the Hubble
Distance and
relation,
speed. Don't forget speed. You got to put the speed in
right?
there.
Well, they don't know how to take the speed out. All they have is the redshift.
Well, then how do you explain
what about
how do you
red?
explain a galaxy connected to a quasar? Physically connected through a bridge of plasma
Well, they
and
ignore
the
that.
different redshifts. So, I
They
mean,
ignore that.
of course they do because it throws a wrench right into the machinery that they're working on.
I think their claim is that the distant quasar that is apparently attached to the galaxy is far, far, far away, and they're not actually connected. It's an illusion.
Yeah, but the
So
radio telescopes show
I know
an
all this.
actual physical connection
Well,
between the
they might
two.
also, I don't know if I'm speaking for them, but they might also say it's an anomaly. And they might explain it in similar terms to the way you've done about the age, or the relative age of these elements, and that it was spewed out and so on. But that in general, they still expand
Birthed, I would
the
say.
expanding universe. I think
Birthed,
they
I
might
would
say that.
say.
I beg your pardon?
Birthed, like
Yeah,
like
well, they would
like
accept
a
that. That's what
child.
I'm saying. They would accept that, and they would accept your explanation there, or
All right, we're going to get cut off here
perhaps.
pretty quick. I think we have 5 minutes. Um,
What are the arguments that the redshift could, in part, represent age as opposed to distance
That's
of
what
the?
ARP says.
yeah, but not for mature galaxies. He's talking about quasars.
Oh, I don't think there are any blue shifted quasars. They're all red shifted.
Correct. Although, and so that isn't really dealt with by these tired light theories. I didn't really make that as a point. I think Monty would say that the quasars are redshifted, but they're not as far away as we think they are because of the model corrections that they put into it that make them look further away than they really are. But I don't think that explains the fact that they're connected to a galaxy.
It doesn't. It absolutely doesn't. And I mean, you cannot discount this observational proof that a highly redshifted object that's supposed to be speeding away from us and the galaxy that it's supposedly in behind is physically connected.
Okay, but this is a different topic than what we're talking about. We're talking about theories that are trying to explain the
Right.
general.
Well, we're talking about ARP's theory of youthful light as opposed to old light. And we're talking about the tired light theory being meshed together to show how the universe is. Shows how light propagates and going through plasma, it loses energy and gets tired and changes its redshift. There's all of that.
Well, in the case of quasars, I don't think anybody's really tried. I think probably if you looked into it, you'd find that people have tried to explain the quasar redshift due to tired light, but I think it's controversial, and I don't think anybody. I don't know that enough about it to comment whether it's correct or not correct. I'm just
We know
on these theories that people are proposing um, that
we know that there's a Doppler effect to the light. That's proven, that's showable. We know from ARP's work, I know from ARP's work, that a youthful light is red, an older light is blue, and the tired light, all of those tied together, working together is our universe. That's what I think.
well, we haven't, none of these theories, I didn't comment on this, but these theories don't really, also the tired light theories don't really they don't address the quantized redshift effect, and which is another issue relating to
Of
redshift.
course, of course. How many quadrants we have, sir? Harry, do you have any information about?
What? Information about what?
About how many quasars we have in the universe? We
I'm not
watched,
sure.
we observed.
I'm not sure I understand what you're talking about. You know what I'm saying? I'm talking about what they call quantized redshifts.
Yes, I know all this stuff. There is no explanation for quantized.
All right. Okay.
Yeah, I know.
I've got a phone call here.
Well, this whole static or steady universe idea, I welcome, because it seems like Harry is documenting a trend where binary mechanics cosmology is the favored cosmology. In the next section, I'd like to hear from Ian and his slides, which might further clarify some of these issues. I certainly would vote for that.
Well, I'd be happy to do that, or at a subsequent occasion, if Harry wishes. It's a bit theoretical. I better warn you. It's a little theoretical, but I hope I would.
Okay. Ian, do you want to go ahead and give your slides for
Yeah,
us?
I probably could. I'll have to be a bit rapid, to go through. There might be about five slides or something.
Can I
But
say just one thing before you start, Ian?
of course.
Sure.
When you're driving and you look in your rear view mirror and it says a little phrase down at the bottom of the rear view mirror, objects are closer than they appear. That's the universe in my view. Go ahead.
Well, that would agree with what the tired light models are trying to get at. All right, go ahead, Ian.
Yeah. Okay. Well, shall I share my screen, or
Sure, go ahead.
share? Yeah. Send request. I haven't done this for a while.
Okay.
Okay. So I just put my thing up, do I? Let's see. Can everybody see that?
No,
Okay. So I have to do something, do I? Else.
you have to go and go to the page where you select what it is you want to share.
Yeah, I'm there. I've put it up anyway. Do I have to press share again?
I think so.
Where do I do that?
It's a green box, I think. When you clicked on the what you want to share, then you have to, I think, click on the green box at the
Do it
bottom.
again, maybe. Okay. So is that better?
Yeah.
Can you see it now?
Yeah, it's coming up.
Yeah.
There we go. All right.
Okay. Okay. Well, You see, when we were talking about this connection, I intimated that Monty had been largely responsible for my development, the development of my theories, my theoretical theories. And I wanted to show maybe how this had been done. So I just call it redshift through energy dissipation. And wait a minute, can I go on to the next slide now easily? Be able to do that.
Okay. Before you go on, by
Yeah.
dissipation, you mean some kind of an attenuation of the signal.
Yes, quite so. Yes, in terms of energy.
So the EM wave is losing energy through some dissipation phenomenon.
Yes.
In
Yeah.
engineering, we mean dissipation usually means loss in a resistor or some resistor.
Well, that's exactly it, because my analogies are precisely of that nature. I mean, you could call it attenuation, or you could call it, like an I squared R type thing. Yes, it's
All right.
okay, fine. So, so I saw this when I was working on this. Now it's going back many, many years. Because I've been aware of Monty's paper for maybe almost 30 years, but I saw it as a continuation of the work of Maxwell. Because if you look at the treatise on electricity and magnetism, volume 2, chapter 20, electromagnetic theory of light, and I've given the reference there, you'll find that his equations, expressed admittedly in quaternion form, include I think he calls it C, maybe in Gothic script or something. It's the conductivity of the ether. And Monty, as Harry intimated earlier in his paper Theory of Relativity, Critical Analysis, 1996, he goes through all the experiments, of course, but he says, why have we neglected this conductivity? And using modern terminology, we call it sigma. In Siemens per meter, it would be sigma naught would be the conductivity of the ether. So my work, actually, I claim, would follow in line from Maxwell and through Monty to my humble self. My earlier paper in Galilean electrodynamics, and then the update on that at the Russian conference, Space-Time Gravitation in 2004. And I've also written another paper more recently, which I think I gave a presentation on the electromagnetic waves anomaly, no analogy. There should be an analogy between ordinary types of waves, such as sound waves and electromagnetic waves. Now, being a bit of a person who likes to go for tangents, I just say one thing. There's a fundamental logical fallacy called consequentum infermans in Latin, which means affirming the consequent. So, in other words, the fallacy is that given that A always implies B, then B always implies A. That's a logical fallacy. So, for example, if A is the recession of emitting object from observer, and B is spectral redshift, it is true that whenever you have an emitting object which is receding from an observer, um, it results in a spectral redshift. That's true. But that doesn't mean that if you observe a spectral redshift, that means that the emitting body is receding from the observer. There could be other explanations. So
Agreed.
you see that straight away. But I claim the mainstream have just gone to this logical fallacy. They said it must be. Now, what I did, I have to be quite brief now. Tell me if I'm running out of time, Harry. Uh, what I did in my analogy paper is I modeled the ether as an infinite transmission line with inductors and capacitors there and so on. And if you do that, you get the speed of the wave through it is 1 over the square root of LC. However, this is a lossless situation, and in reality, I would claim there should be a little resistance there, which provides some leakage, and there should be a parallel conductance G, uh, which would provide a leakage. So, sorry, there's some leakage through a conductance there, and there's some
Resistance.
loss. Yeah, a resistance there. So I haven't actually put those in, but if you do that, you get the telegrapher's equation. This is all well known in electrical theory. I mean, okay, so it's a bit theoretical. I have to apologize for this, but and I'm going through very quickly. But so if you do that, what you do is you get a wave equation, but it doesn't merely equal this bit here. You know, you have additional terms such as dissipation proportional to the rate of change of the function, and k would be the factor there. And there's also another one, a dissipation just proportional to the function, and gamma would be the factor there. And this is well known. So the solution is a damped compound of harmonic motion in x and t, the spatial and time coordinates. And the damping coefficient is this, the exponential of, say in terms of distance is minus kx over 2c. C is 1 over the square root of LC. K is G over C. These are the loss factors, and L, R over L, and gamma is that. Now, this was actually done in 1866, when they succeeded in having the first transatlantic submarine cable from Valentia in southwest Ireland to Newfoundland in North America before it was part of Canada. So this was all done, and Kelvin was working on all these factors here. So what I did is I just wrote down some generalized Maxwell equations. It's a bit opaque, I confess, because what I mean by the curly brackets here is that in free space with no additional charge, you take one at a time. The divergence of E is 0, divergence of H is 0. You take one at a time. So, for example, this is one of the equations. The curl of E plus or minus the permeability of H differentiated partially with respect to time is equal to the resistivity times H. And similarly, the curl of H plus or minus the permittivity of E, the rate of change of that is sigma naught. Now here's the change, because sigma naught is the conductivity. So that's put into the equation. If you just remember in simple terms, the Maxwell equations, which is basically, from the Ampere Maxwell law, that the curl of B is equal to, a proportional mu naught J, which is the current density, plus the other. I know there's an argument on the internet at the moment, or on the emails, about the what's it called, they're arguing about the dissipation, the delta D by delta T, the what's it called, the type of current. God,
displacement.
Displacement time. So if you equate that, if you say, well, there's an E there, just use Ohm's law. Basically, you get you get that the displacement current is sigma naught E. That's just using Ohm's law in vector form, and the plus and minus terms are taken in order. So if you work it out for the transmission line, you get the K factor, which is the proportionality factor for the rate of change of the function. You get this. Remember, rho naught is the resistivity of free space, epsilon naught is the permittivity, c squared is speed of light, sigma naught is the conductivity, mu naught is the permeability, and c naught. So you get that. Now, at electromagnetic frequencies, however, you basically get that what is important is the leakage, not the loss. So at very high frequencies you get K, gamma disappears, and K is basically just the ratio between the conductivity and the permittivity. Yeah, sorry. So you might be interested in saying that for sound, this has been worked out by Lord Rayleigh. You get the K factor is exactly the same. It looks similar, and gamma's naught. Anyway, so I'm going to show how Monty just did that, and how I took his values as well, because Harry referred to this a moment. But basically, just 2 lines before I get to that. The redshift data gave the value of sigma naught. So Monty actually analyzes the redshift data from observation of distant galaxies using this exponential law. And I actually cast it in a slightly different form, just looking at the surface, the Poynting vector, and the divergence of that, and so on. And I found in my figures that the energy would reduce by the factor of epsilon of e to 1, the base of Napierian logarithms, after about 10 to the 10 gigalight years. Now I'll show you how that came from Monty's values now. Well, maybe just one more equation. The electromagnetic wave equation. So I say Maxwell's equations, including conductivity, give a D'Alembert, which does not vanish. So the normal in the theory of relativity, and Jim was asking this earlier, there's no ether, so therefore the conductivity is zero. There's no conductivity. Well, the wave equation that equals zero. The D'Alembert, which is that squared minus that is equal to zero. But actually, if you include this term, you get that. That's the dissipation term. Okay, so R naught is the impedance of the ether, if you like, and sigma naught is the conductivity, and so on and so forth. Okay, now the inverse of that would be a dielectric rigidity, which would mean the field that in volts per meter that you'd have to impose upon free space, let's call it, for it to break down. Now, the theory of relativity says you'd have to impose an infinite potential gradient to do that. But Trowbridge in 1897 actually measured a non-infinite dielectric rigidity before free space or the ether would break down. Now, what you do then is you solve the partial differential equations, and you provide an exponential dissipation in the Poynting vector, which is that. So it's right to RD, where RD is that. So the sigma naught comes in and the impedance of the ether. Now, so again, using Planck's law equals h nu, relating energy quantity and frequency, you can relate the energy dissipation in the EM wave to a spectroscopic redshift. And, this is just repeating what Monty has already said, and Harry explained it as well. It actually gives a better than an expanding universe. The luminosities and recession speeds, do not go up dramatically. And the age of the universe, there's a problem with that. And also, they claim the 2.7 Kelvin background radiation, follows that. It doesn't at all, actually. Now, Monty actually in his paper looked at all these values, and he actually evaluated, these are Monty's figures, not mine. He evaluated about 2.85 times 10 to the minus 29 Siemens per meter. Very, very small, but not zero. And then this is my terminology. I call it the dissipation distance, the distance, after which it is decreased to E over 1 of its value, or 1 over E of its value. I get about 10 to the 10 light years. And Monty has also plugged in these values to get a dielectric rigidity of about 4 by 10 to the power of 20 volts per meter, tired light. So let me just show you a graph now, because Harry referred to this as well. Monty talked about what we might call the Hubble linear law and the Maxwell linear law. Well, I've just normalize the distance this way, R over RD, my dissipation distance. And the normal I change the wavelength is the Z factor. And you can see that this thing goes right off to infinity. And, once Z gets quite large, you have to start postulating very large distances and, inconceivable luminosities of these values. Whereas actually, if you plug in this dissipated Maxwell law, you get a reasonable curve like that.
Okay, so the one on the left, which looks like it's blue, is the linear law.
Yes.
That he's talking about, and the one that's below that's in the red is the what he calls the logarithmic law. And
yeah. Or I call it the exponential law. I think actually he has a graph, and I think he has it the other way around. I think he has this on the y-axis and that on the x, and therefore it's like a logarithmic law. And I've just cast it back to an exponential law.
Right. Well, the logarithmic law is inverse to the exponential, so it's a natural logarithm that he's talking about, I think.
Correct. That's quite so. Yeah. Actually, my system is basically the same as Monty's. It's basically just taken his model.
So the bottom line is that according to the um, exponential decay law, okay, objects are closer than they think according to the way standard cosmology estimates their distances.
Yes, yeah, yes. That's a very important point.
Okay, is this the end of it for you?
I think it is. Let me just. There might be one more. Well, conclusion. This is the last slide. Yeah, but it's we've said it already. Apologies for my speed. Physical properties of medium for electromagnetic propagation correspond one-to-one for media of other waves and are governed by the same equations. So I've gone into a bit of theoretical things, but all those equations appear actually in Maxwell's original work in 1861 and also in Lord Rayleigh's theory of sound. It's the same equations, basically. Treating EM radiation analogously to other waves leads to a more rational description of phenomena, in particular redshift data and causal explanation. Yeah, so that's what he said. So that's the end of this very short presentation, Harry. Maybe I'll.
Yeah, that would be a good presentation for this upcoming Saturday.
Well, I did think of that, and unfortunately I sent. I've been very, very busy, and I didn't think I'd even have time to say anything to you today. But I just really,
I know, I saw that. Maybe
yeah.
I don't know what we're good. Okay, I don't know what to do.
Roger, I don't know if this is good news or bad news. Rock that
All right,
vacant spot next Saturday.
all right, that's what I figured.
Yeah, so maybe at a later stage, I might expand this
All right,
and give more detail.
okay.
Your universe seems very electric, Ian.
Yes, okay, there is a similarity between your sort of ideas, you plural, and mine, but I don't share all your ideas. But yes, that's probably true, Rick.
I would say, I guess the question that immediately follows from that is, it's not real clear to me from what Monty says in his paper and what you've said, whether or not the attenuation is due to a plasma or just due to the ether, or how this attenuation takes place.
Well, I think, Harry, neither I nor Monty gives any explanation for it. Monty says, look, special relativity was wrong to omit that conductivity term, to omit ether and therefore omit the conductivity term. And I have concurred with that, and I've shown that all other types of wave motion has this conductivity term, and we have to evaluate what it is for light. But how the mechanism occurs, whether it's a Compton thing, whether it's plasma, whether it's the other, that's for experimental physicists to determine, perhaps.
So we're back to what I was trying to say, which is that if you believe in the ether, you could claim that redshift is a proof of the ether.
Yes, I certainly would concur with that. But that's completely backwards with regard to how mainstream consider things. So it's a revolutionary idea, but yet it's so obvious, it's so evident. It should have been considered. And I claim that this logical fallacy, you'd say, oh God, none of these very academic people would run into that logical fallacy. But I think they've jumped, to assuming that because we notice redshift, there must be a Doppler shift. And when you say no, here are other, they say, yeah, no, we couldn't accept that because you better explain to us in detail how it actually works. Otherwise, we could not accept. Well, I say I don't know exactly how it works, but I know that there is a mechanism in all of the types of wave motion for a dissipation, and it's caused by air in the terms of sound waves. It's caused by water in terms of water waves. It's caused by maybe earth in the case of seismic waves, and it's caused by ether in the case of electromagnetic radiation.
There has to be a medium.
Quite
there
so.
has to be. There is no propagation without a medium. And until we find that medium and understand that medium and understand its properties, we will stagnate as a species.
Well, that's a bit.
Yeah.
There's a lot of other ways we're stagnating as a species.
Yeah. I haven't gone quite that far, but yeah.
Well, think of the implications that arise of finding the ether and understanding how it can create matter from basically the energy that the ether is.
Yeah, let me
It's
tell
a
you one comment. Maxwell equations are classical equations. In classical equations, you can have only conductivity without explanation. What does it mean? You can measure it in a classical view. And what is the measure? It's a business of quantum physics, and you are not in this business. That's why they're asking you for something else. Maxwell equations, it's classical physics. Conductivity, it's a classical physics. You cannot tell anything about quantum physics. I'm very sorry, man. You're absolutely right. Nobody knows what does it mean conductivity. I mean quantum physical mechanism, how it works. But you can measure it and put it in your classical equations and work with it. That's it.
I'd like to submit
That's
that
why there
the
is no
quantum
need in your excuses. I'm very sorry. You can stay in as a classical physicist with conductivity, and that's it.
is the quantum realm even a reality? Bosons, quarks, but no.
Oh, yeah.
Okay.
Sorry, I'm just surprised, Harry and gentlemen, that this omission of this fundamental constant has not been highlighted sufficiently. I mean, the mainstream are saying, if you read the popular literature, it says, well, Albert Einstein said, I haven't relied primarily on Isaac Newton. I have relied on James Clerk Maxwell. And he had a picture of Maxwell on his wall and so on and so forth. Special relativity is completely compatible with Maxwell's theory and so on. It has omitted one of the most fundamental
Oh,
aspects.
I see your point. Yeah. Yeah.
Exactly. Exactly.
Well, that's kind of one of the. Um, I think it's good if we got that out of what my talk was. That was one of the things I wanted to emphasize in the talk. That there's an alternative way to interpret the redshift, um, aside from making the assumption that the universe is an empty void space.
There may be many alternative ways to interpret redshift, and they may all work together.
Yeah, well, there's a lot of theories that I mentioned. I brought that. Part of the reason was I wanted to bring out all the different ideas that had been put forward, and I'm sure my little talk today didn't cover all of what has been put forward. All the
Well,
different.
you left ARP out.
I don't know that Art proposes
A youth
tired light theory.
he doesn't propose a tired light theory. He proposes a youthful light theory. The redshift is based on the youth of an object, not its distance and velocity away from us.
Okay, well, I understand what he says. I didn't really put it in the category that I'm talking about today. I'm not really sure he even has a static or expanding or not. So I'd have to look into that.
Well, ARP believed in a static universe, a non-expanding universe. Let's put it that way.
Well, I have to look that up and see. Okay, maybe that's something that you can give us a talk on.
On Halton ARP and his theory?
Yeah. Why don't you give us a talk on that topic? rather than me doing it.
I'm not a very good orator.
Yeah, right. Okay. Yeah, when it comes to interjecting, you're pretty good at it, but okay.
Yeah. Well, it would be interesting
Well,
to
I
see
mean,
whether
interjection is interjection. That's not oration. So
it'd be interesting to see whether your enunciation of ARP's ideas uh, were such that this was a general phenomenon, that redshift was just proportional or in some functional way related to age and so on. Or, as I thought earlier, and maybe I'm wrong in interpreting you, that it was an anomaly. There were certain anomalous cases where there were, elements connected to a galaxy with different ages and so on. But if you
well,
say this is a
you see,
general thing,
you
we'd
see,
like to know.
ARP's theory says that galaxies that are connected are being spat out through uh, their spiral arms. He also says that they get ejected out through the access through the black hole jets. Matter gets
Yeah, yeah.
and then they accumulate and they start making a quasar that then in turn grows into a galaxy. That
Yeah.
growth is due probably to drawing other matter in the area around into it, and possibly, I think, the creation of new matter in the stars that it's going to that these quasars are creating, and they're growing and making new stars, and it's a I think matter is being created in stars.
Yeah, but this is concerning the birth and development of quasars. But
Right.
what I'm saying is, if you have objects in the universe and one has twice the redshift of another,
Hmm.
is the same phenomenon that you're trying to explain
He's
there?
talking. ARP talks about quantized rate redshift as as an object gets older and older and older, its redshift drops, and slowly, eventually, will turn into a blue shifted object over time.
My goodness, it's unbelievable.
Okay.
Man, stop talking about redshift and then blue shift. It's
All
against the
right.
logic.
All right. Yeah, and I explained that the Doppler effect does apply to certain objects that are moving towards us. Other objects that aren't moving towards us doesn't apply. Maybe some other mechanism applies, like tired light, and the ARP's youthful quantized redshift.
You see,
I have
I
no
have no
words.
problem
Combination of
accepting
them would
some of these
explain a lot
things
of things.
as I call them anomalies, but things that could exist in certain areas, in spiral arms or birth of quasars or whatever. But today we've been talking about the primary cause of an increasing spectral redshift with distance. That's generally conceded, and we want to know why that is the case. And it appears to me that perhaps ARP's discussion is not dealing with that.
Well,
I mean, you're
it
not
kind
saying
of
this, are
does.
you?
It kind of does because it's showing that these objects that are very, very distant, maybe the redshift implies tired light. These objects that are closer to us, maybe if they're moving towards us, will be blue shifted. The it, it, it
Oops.
who knows? We're so young into astronomy that we haven't tracked everything. We haven't seen them moving. We need another 1,000 years of observations so that we can understand fully what's going on.
Well, let's hope so, that they do figure it out. But the way they're going, I don't know is they're on the right track right now.
Well, they're not, but I mean,
Yeah, that's what I'm trying. That's what I'm talking about.
yeah.
Uh, the I'm just giving a taste. I mean, my presentation today was just a taste, just a
Mhm.
brief look at alternative ideas that have been put forward.
Yeah, you
And
do a great job as always. Sorry, go ahead.
I didn't address Arp's ideas because I don't think they're, you know, what he says is kind of, you know, I'm pretty familiar with what he says, and I understand what you're saying, and it does relate to what he's saying,
Hmm.
and maybe at some point I can convince you to give a talk on this subject because certainly would be interesting.
Okay,
Okay,
I'll think about it.
all right, we're getting towards the end here. We got about 7 minutes. Um, Robert, you haven't said anything.
Not today, but
I've seen him smiling a lot.
yeah,
No, I saw that too, and I'm thinking, are the wheels turning, or what's turning in there?
yeah. I don't know if I have anything all that novel to contribute on this part, but I mean, redshift. I always took redshift to mean that something was going away, and blue shift that was coming towards you, which would just be off of a Doppler effect. But
Yes.
but what you say about the fallacy of affirming the consequent, I mean, that is the principle in logic, and you're absolutely right. You can never, just because a theory makes a prediction and you have the observation in accordance with the prediction, it doesn't prove the theory because there might be an alternative one. I think what you're showing is there are alternative explanations for redshifts.
Yeah, that's basically my point.
Mhm.
Other possibilities of an
Right,
explanation for redshift.
right.
It,
That's what
it
we're.
can't. You can't.
Mostly
You
there is
can't.
no even one explanation for blue shift.
Well, I have to look at that. I'm gonna take a look at that. And,
Well, ARP would say that it's a measure of youth.
yeah,
A blue shifted object is very, very old. Large galaxies tend to be blue shifted. Very large galaxies tend to be blue shifted. There's large galaxies that are red shifted, obviously, but they're very distant, and that could be tired light. Again, it could be a combination. Our observations of the color of light could be a combination of factors.
well, as it stands now, they've adopted a certain paradigm, and the paradigm is the expanding space model based on general relativity, which they claim predicts uh, the what I prefer to call them an unstable universe. Universe that's expanding, and they've run into problems with that model, and they've made a bunch of ad hoc corrections by adding in inflation and dark matter and dark energy, and their predictions are running up against the problem that they're finding mature galaxies that shouldn't exist at very high redshifts, implying very young ages. So that galaxies couldn't have formed as early as the JWST is showing, and therefore that puts their origin of the universe and their theory kind of in doubt, and so gives an opportunity for people to talk about alternatives, because the standard cosmology, it kind of becomes a form of dictatorial conformity. You must conform to the standard cosmology.
Religion. You could call it a religion.
Yeah, and it's kind of, we had a talk about that a couple of weeks ago. That dictatorial view of the universe is coming under question and at the current time. So it's kind of an exciting time for us. If you're interested in science and cosmology, their paradigm is apparently crumbling.
Yeah, cosmology is broken, and I think the electric universe fixes it.
Well, certainly
The
quite
electric
recently,
universe
before the
certainly fixed the.
JWST, if you did say something like that, you would just be cut off, you know. But there is a possibility of airing those views now because, as Harry says, there are some holes appearing, and it's quite acceptable to say that. Just very quite recently to say that.
Okay, I guess Roger is going to come up with something to talk about on Saturday, and
He sent out an email pretty soon after I sent the other one out
all
because I
right.
just got back. It's on. Oh goodness me, it's the same sort of subject as he deals with.
You had suggested that we move the discussion to Saturday, and I guess we won't do that. We'll just
Right.
keep it on Sunday and um, um, let Roger talk.
Yeah, I might be able to find out what he said.
Think about his talk yesterday. What is your opinion about
I'll give you
different
my
view
opinion.
of
You want
special
my opinion?
relativity?
You want my
Yes.
opinion? I think it's a waste of time to talk about different views on relativity. I think the bottom line is that general special relativity is wrong, and the correct theory is Lorentz's theory, as I've presented it in my papers at the General Science Journal. That gives a correct theory of what's going on, and there's no need to talk about general special relativity because we know it's wrong. The only issue is we can't agree on a correct theory that replaces it. Does that answer your
Fortunately, in
question?
university, still Einstein, still special relativity, all these bullshits in heads of a new physicist. This is the main point. The main point. We're doing the wrong work with students. We give them the information that's obsolete. It's wrong. That's why
Right.
I support his talk
Yeah,
yesterday, because this is the way. We must stop this bullshitting. We must
and he's
give
Right.
them
proposing
new ideas.
he's proposing to speak on Boscovich next week,
Yeah.
and particularly that he's proposing that Boscovich's theory should be taught to
Yeah.
students and not being.
Well, my proposal is that we agree on a theory, and my proposal is my modified Lorentz theory that's described at the General Science Journal as the correct theory to replace Einstein's relativity. I think talking about relativity and different versions, we need to find what's the correct theory. I propose the correct theory. Nobody talks about it.
Well, the
Roger's
electric
known as the
universe,
correct
the
theory
ele
for a
the
long time.
electric universe theory